If you do any amount of scratch building, building wooden ships, RC airplanes, or basically making anything, you'll more than likely want to add a sanding machine to your shop. There's certainly no shortage of these machines. Many of them are available at your local home improvement store or discount tool outlet. If you look online, you can be overwhelmed. Quality can be a bit hit and miss, as it's usually consistent with the low price. Most all sanding machines fall into three basic types: disc, belt, or spindle. The most common sanding machines out there, though, seem to be the inexpensive combination belt and disc types. At first glance, they seem to be like a pretty good idea, two for the price of one. But which one of these really works best for our small hobbies? Probably the fastest way to sort it out is to start with what features we as model makers would most like to have. In my case, since I build with a variety of materials, the one absolute requirement, the one deal breaker, is speed control. And although usually listed in RPMs, the critical speed with a sanding machine is the speed of the abrasive surface. In the case of a belt or spindle sander, the speed's the same across the entire abrasive surface. However, with a disc sander, the surface speed's greater to the outside of the disc. So if you're working with a piece of plastic, you'll probably want to stay closer to the center of the disc. Speed can be controlled either electrically or with a belt system. Unfortunately, all those inexpensive small combination sanders use a direct drive AC motor that only runs at 3450. As long as you're careful, the speed works okay for wood, but if you try to sand any sort of plastic, you're going to wind up melting it in no time flat. Like any tool, using a sanding machine means developing some skill and technique. How comfortable you are around the machine and the feel you develop for feeding the material is going to go a long way to the success you're going to have using the sanding machine. But you need to have a machine that provides a very consistent abrasive surface so you can accurately work up to a line, dust off a few thousandths, or correct that angle a few degrees. Belt sanders use a moving abrasive belt. As a result, there's a lot of room for error. The metal backing on these inexpensive strip sanders can be fairly flexible, so setting an angle is pretty much an approximation. Wide belts, even on heavier machines where they're backed by a substantial steel footplate, are susceptible to buckling. And while this may not be a big issue if you're using more pressure against the belt, like when you're sanding a thick piece of hardwood, it's a problem for model making where we use smaller, softer materials. Belt sanders do have a big advantage of running cooler, so they're far less likely to burn a material if you're doing heavy reduction or sanding metal. But in general, I think their usefulness in modeling is pretty limited. Because the abrasive is actually attached to a rigid surface, a disc sander has the potential for being the most precise of the sanding machines. However, if the disc has a lot of runout or the surface isn't flat, then your material is going to bounce against the disc. Here you can see how the material only made contact with the surface at the high spots of the disc. This is going to make it pretty hard to shave off those small amounts of material or establish that precise angle. And all the technique in the world isn't going to save you if you're waiting for the next high spot on the disc to come around again. You can do a quick rough check for the runout in any new disc sander. Before you apply the abrasive disc, you can simply run your fingernail or a block of wood against the moving disc surface. As you move from the inside to the outside, you should feel an even, constant contact against the disc surface. If you feel a vibration or hear a ticking sound, you have a pretty good idea that you have a problem. Another consideration you might want to think about is how well does it fit into your workspace? And is the size of the machine appropriate for the work you're doing? This machine probably isn't going to be a good choice for most hobby rooms. When you really take these factors into account, I doubt you'll find any of those inexpensive combination sanders very useful. I've auditioned a number of them over the years and I've always found the speed to be way too fast. Precision wasn't their strong suit, and they occupy quite a lot of real estate. If I could have only one sanding machine, though, for model making, this would be the one. It's a variable speed 10-inch disc sander. The great aspect of this sander is the slow speed. It uses a belt drive so that even at top speed, the disc speed never exceeds 500 RPM. There's no lack of torque even down to the low end of the speed range. The disc is virtually dead on with almost zero run out. The unit was sold under the Micromark brand and I bought it some years ago. However, it disappeared from their catalog for a while, and now it seems to be back under the original proxxon label in colors. Keep in mind that proxxon tools are available from any number of retailers, even Amazon. In the interim, proxxon's made some very nice improvements by updating the front portion of the case to make the sander more stable, and they've given the table a very nice T-slide with a much better miter gauge. So let's take a closer look at the sander. You can see how the case of the Micromark unit is cut back. This made the footprint too narrow to adequately keep the sander upright when you put any pressure on the table. So it was absolutely necessary to mount it to a wood base. And even though proxxon has widened the base, given the size of the sander, I think it's still a good idea to mount it to a larger base for increased stability. On the back you can see the on and off switch, the speed control, as well as the vacuum hookup. Miter gauges on large sanding machines like this are heavy, so they stay in place on their own accord. But on these small machines, miter gauges are frequently light and flimsy. You can spend as much effort making sure the gauge is still in the track as you do feeding the material. Proxxon's addressed this issue by using a T-slot table that keeps the miter gauge where it belongs. It's a great idea, and after using it, I'd have to say it's pretty much a must-have. The larger 10-inch disc allows you to easily handle most modeling tasks. And remember, with a disc sander, your working area is less than half the diameter of the disc because the disc doesn't do any cutting in the center. Here I'm testing the sander with some styrene. You can see how cleanly the slow speed cuts the styrene without melting it. The one drawback of the sander is the size. For most modelers working on a single bench, they more than likely not have room for this sander. Here I am working away at the bench. I'm on a roll. I've got this small piece that needs some precise touching up. And ideally, I want a small sander that's just right here at my workspace. One thing I've learned over the years is that convenience is the key. If it's handy, you'll use it. Otherwise, half the time you'll reach for something else that you think you can get away with and just take a chance. So here's a small 5-inch sander that's ideal. In reality, it's the one I go to most often. In my opinion, the one that knocks it out of the park is the proxxon. You can see how well it fits on the bench. It's an ideal working height. The on and off switch is easy to reach, and this makes the unit accessible so you'll actually find yourself using it all the time. The speed's controlled electronically and it works very well. The unit's extremely powerful even when slowed way down, making it an ideal unit for all materials. It has that same great T-slot table and miter gauge system used on the larger 10-inch sander. When Proxxon first introduced this sander, they tried a composite disc that proved to be an issue. But all the later units use an aluminum disc with a unique applique surface that allows easy changing and reuse of the abrasive discs. This makes it much easier to select the right grit. And I found as long as you're careful and keep the dust off the adhesive surface, the system worked out pretty well, and I haven't had any problems with the disc not staying put. I honestly can't say enough good things about this jewel. It's just what the doctor ordered. I wish I would have had this unit years ago. At the other end of the spectrum, there's a small 5-inch disc sander sold by Micromark. I've found this unit to be extremely disappointing. It runs at a ridiculously high speed, so fast in fact that they mount it to what feels like a 10-pound base. Let's fire this up. So you say, why not use a speed control? Okay. So now I've attached a speed control. Well, the disc is turning slower. Oh, wait a minute. There seems to be a problem. I tried to sand something. Suffice it to say, I wasted my money on this machine as well as the speed control. One other small sander that I want to make you aware of is from Burns. Burns manufactures some of the finest small power tools available. Because their line is mainly aimed at miniature woodworking, they're very popular with wooden chip modelers. The Burns disc sander is very elegant in design. It's rock solid and very precise. Unfortunately, it has a fixed speed that works well for wood, but it limits its use for other materials. The last type of sander that I want to mention is the spindle sander. These are sort of a one-trick pony, but if you're going to be sanding into curves, you really need one. And this sander gets a fair amount of use in my shop, especially when sanding lifts for ship's hulls. What makes this sander different from, say, using a sanding drum in your drill press is that the drum oscillates up and down. This allows the drum to wear evenly and ensures a flat edge on whatever you're sanding. There are a bunch of these out there, so pick one that fits your work area and gets good user reviews. This particular machine has a nice heavy smooth surface table, which is what I prefer. One thing to watch out for. Some of these spindle sanders are sold with a tilting table, and at first blush it seems like a pretty good idea, but think about it. You're setting your angle against a circular drum, so the minute your work area comes in contact with the drum at any other point, the angle is going to be different. So the tilting table is sort of a non-feature. Well, that about sums up my quick look at hobby sanders, but I want to add one final note you might want to keep in mind when it comes to hobby tools. Hobbies are a very small segment, and as the world changes, hobbies seem to change as well. Tools that are available today may not be there tomorrow. So nowadays, I'm a lot less likely to put off a purchase if I see something that's really useful. Take care, and I'll see you next time.